Hi guys, and welcome back to your pick and place. I'm going to be running through how to set up components in a tray today. So the bulk tray component stuff. Got here a old strip of components. These are LEDs. I think they're a 1210 package. Dual LEDs, and as you can see the strip is really knackered. I've got components missing in here from the middle, and I've got components at either end, so it's not really suitable for a tape feed or anything like that, or to be reeled on. It's falling apart really. So perfectly suitable though, because the components are 100% fine for a tray or something like that. So that's what we're going to be doing today. Now the first thing that you need to do is to measure your components. So grab yourself a pen and paper, because you have to take some notes. Measure your components, widths, heights, and already dropping out the out of here. So measure your widths, the heights, the lengths, and so on. Don't care about the real tape or anything, because we're not using that. And we'll get this into the machine. And what I'll do is I'll show you how to set up the library. So I run through libraries for the trays. We'll set it up in the feeder, which will be in the carrier. It won't be in the tape feeder. And learn how to use the look up, look down camera, and I'll show you how to run you through a little calculation I came up with to accurately pick up these from the tray, because it's a little bit different setup where you set the height than it will be on a tape. So let's get down to the machine. Alright, and so we've got our bulk feeder down here. Got some components already loaded up in this from the past. We've got some caps, some large caps, smaller ones, some diodes, a few chips, whatnot. So the numbering convention for these trays doesn't actually conform to the numbering convention in the software. So in here we've got 1 to 12 by 1 to 6, 6 rows by 12 columns if you like. So I've got about 72, 80, about 72 I think it is, ain't it? Yeah, 6 times 12, yeah, 72. 72 holders for components. Now, like I said in the introduction one, I am in the process of making a larger one of these. Hasn't got as many holders, but the holders are a lot larger, so I can hold a lot more components in these individual trays. Basically, try and come up with some sort of numbering convention for your tray, and then that will follow through on your software side. So what I normally do is I normally do 1 to 12, 12 to 24, 24 to 36, and so on going down. That's where I do it, in going down in columns or in rows or whatever you want. But come up with some sort of numbering convention. When I get the new one made up, I'll have a different convention, but I'll have a lot wider choice about components that I can actually fit into these. Because if you take a look, I've got some SO 14 packages here. I can only really get one at a time in these feeders, so it's not much use if I've got half a dozen of these. Too few for a vibratory feeder. Don't go on a reel, you don't go into the tape, you get them in the tube, but I've only got a couple, so you put them into these. But the smaller ones, a little bit useless for anything larger than an SO8 or something. Even SO8s, you'll only get about 2 in one of those. Now, got my LEDs here. When you put these in, peel your tape off and whack them in the holders. Ideally you want to do a little bit of Esd Protection, but nah, who cares? They're only LEDs. Alright, so put them in the holders. Make sure that they're all pad side down. So you can see that now. Just zoom in. There we go, got my LEDs in there. Pad side down, definitely, because when you pick up with the head, it'll be in place on the board. You want your pads on the bottom side, so pads down. And when you place these components, make sure that you have one, preferably around the middle, orthogonal. So if when we do our component recognition, you've got one that's square. 'Cause when you do the training, you have to make sure that your component is square in the carrier. So whack one around the centre. Now these are diodes, so my polarity is on the right hand side, denoted by a dot in the middle, and yeah, it's also denoted on the underside as well. But so in the training stuff, we're going to have to sort out polarity, which I didn't do in the last one, so we'll do something new. Anyways, that's as much as it is for really doing the tray. All that you do is peel off your tape, whack them in the tray, pad side down, and have one square in the centre. So at 0 degrees, you don't want it horizontal, you want it you don't want it vertical, you want it horizontal, you want it nice orthogonal, you want it squared, and yeah, so that's it. So you just whack them in the thing. Make sure that you do measure your component first, make sure that you do measure the height, and make a note of how big the surface area of your component is. Now on the chips before, you pick the nozzle to fit the chip. So if you've got an 805, then you pick a nozzle for an 805 package. This one isn't. This one's like I said, it's a larger one. It's on like a 1210, possibly larger. And it might be a bit of a custom one because it's a dual LED package. We'll soon find out when I measure it. But because it's an LED, you've got the lens on top, and that's an odd shape. So you have to pick a nozzle which will fit to the actual lens. If you pick a nozzle that's too large to the actual package, it's not going to pick up square, it's not going to pick up particularly level, and if your nozzle is larger than your actual lens on your LED, then you're going to lose vacuum, because you're going to have, you know, it's not going to be fully on, and you'll get your component dropping off, or it's not going to get picked up, and you end up with all kinds of problems. So pick a nozzle to actually fit, in this case on our little emitter. Right, so next thing, once this is done, you've got your components in there, you need to take some measurements. Measure your component. I've got one off the strip already. This is measure on the mic. Use your vernier as usual. My height, if you saw that, was 0.66, so 0.65 height. My lengths and widths are, length is 3.2, so it is a 12. Width is 2.7 millimeters, so it's a little bit bigger than a 1210, a little bit wider than a 1210, smaller than the next package size up, so it's an in-between one. So it doesn't actually conform to a known package. I might as well whack that one in as it is. Make sure it is up the right way for future reference. There we go. So make a note of your component sizes, because that's important. Make sure that you've got a little bit of space around your components as well. Don't bunch them up, otherwise the vision recognition will actually screw the pooch and it won't recognise the component, because you've got two components in the window rather than just one. I'll explain that later on. Next thing that you need to do is a couple of measurements to set the actual height that you need to know. So you've got your component height, but you also need to know your the depth of your tray. So using a vernier, make sure it's on for me. The depth of my trays are about 2.3. Let's see if I can get that a little bit more accurate. There you go, that's more accurate. There we go. Did it a bit slower that time. There you go. 2.1, you could say, millimeters. Make a note of that. You need to know the depth of this, because what we'll do is we'll touch onto the top we'll touch onto the bottom. We can work out our depth in steps, because the machine works in steps, or increments if you like. I like to think of it as steps. So it does step height, but we work in millimetres in height for the distance, so you need to do a bit of converting. I'll show you how to do that and how to work out the actual height of your component and so on with relative to the actual machine. And measure your depth, measure your component height, and we can start working out stuff when we set up a component, which is what we'll do now. Alright then, software side of things. So first of all, adding the component into the library. So go into library, browse to the folders that you need. I'm going to chuck into the root, just an example. And we want to do a new package. So LED custom, already listed there because I started filming this before and I ran out of room on the camera, but here we go. LED custom, we're going to call it that. Okay. Custom LEDs in. You want to switch polarity on, set the polarity to the right hand side, so it's 0 degrees in my carrier, its polarity is to the right, that's where the dot is. Type in our length, so length was 3.2, width was 2.7, and my height was 6.5. Once that's done, you go into the picking. Everything down here is perfectly fine, except for the nozzle, which I'm going to pick nozzle 3, which is the 0805, which should fit to my lens perfectly fine. If I go up to the next size up, it's not going to fit on the actual nozzle. Is going to be larger than the area that I can pick up on. So I've got that, you know, the window on the LED that you're picking up on. So nozzle 3 for that. And pattern matching. Can't do any pattern matching yet because we haven't placed it in our feeder. I haven't told it that we're using a tray or anything, so we're not going to be able to find a component or learn it in. So add the component. Yeah, we haven't trained it, and we've got our custom LED, and you can see that polarity's been set with the dot. Okay. Go into feeders. Down into feeders, so these are our bulk feeders down here. I've chucked it into number, what have I chucked it into, 24, 25, 26, 27, 28, I think I chucked it into about 28 or 29, so we'll say container 29 of our bulk container, and we set the pickup position. Now, instead of centering it onto our carrier in the feeder, what we do is we actually train it top left, bottom right corners of our the little bin in our component tray. So we select teaching, top left coordinate, use to quick jump, and we can jump to our components. So as you can see, I've already got some blue crosses here where I've already set up components in the past, and we can say, right, well, let's buzz it to a known component. Let's say this one. These are my caps, and I know that it's in the same row as these caps, so I can just scan it up. There they are, they're our LEDs. You want to adjust your brightness so you can actually see the carrier clearly. So somewhere around there, so you can just see the edges of our carrier. We want the top left, which will be somewhere around there. Yeah, that looks reasonably okay. That's trained into top left, bottom right. We'll train it to a square carrier. And you can say that's the bottom right is right there. Okay. Okay, it's been trained in. Next thing that we want to do is set the pickup height for this. Now then, what we want to do is to measure using the nozzle. So we've got an idea of the top of our tray holder, then we measure again to get the bottom of the tray holder. That way we can subtract the two and work out our tray depth in steps. Now we've already got our tray depth in millimetres, but I need to know the tray depth in steps because the machine works in steps or increments. I'm not too sure what the actual machine works in, either steps or increments, but not the same muchness. So we need to convert millimetres into increments, and in order to do that you need to find out what it is, the difference. So let's measure it. So select an upper portion, either the edge of your tray holder or something that's on the top level, so I'm going in between a tray. So this is our height. Okay, so our top height is 1368. We want to do it again. Set pick up height. Yes, retrain it. And I want to pick an empty carrier, and we're going to measure the bottom of the actual carrier. So we'll do that again. Okay, so it's now 1551. So you got a difference of about 200 steps. So you got 200, maybe a little bit more, 201 steps. And our distance in millimetres was about 2.1. So you can say, you know, you can work it out. So it would be the lower height, which is the larger value, minus the upper height, which is the lower value, gives us our difference. Divide it by the depth, which was 2 millimetres. That gives us our depth height in steps. So, you know, that'll be around 100. Simple. You know, 200 divided by 2, it's 100. That's our step function. What you need to do is you need to minus in millimetres your the depth of your height and the depth of the carrier minus your component height. In our case it was about, I don't know, it will come out to about 1.3 millimetres because the depth was 2 millimetres, component height was about 1.4, 1.5, something like that. I can't remember now. So it works out to be roughly about 1.4 millimetres, and then you add it to your upper height, which was about 1330 or something like that, and that will give you your height. So once you've worked out that, you can add in the height, the ballpark figure. So I did a brain fart and I didn't actually write down the values, I'm not just guessing these. Now from what I can remember, you need to set the pickup height, retrain it, but you want to manually edit. So it'll come out to about, I think it was about 1490 it will come out to, roughly, for this particular component. What I'll do is I'll flash this up now. So this is the formula I came up with. It's basically, you measure with the nozzle your upper height, your lower height. The depth of the holder you measure with some calipers, and the component height you measure with calipers. You do the lower height minus the upper height divided by the depth of the holder. Then you get the holder depth in steps per millimetre. After that, what you want to do is you want to do the holder depth multiplied by the difference in component height. So your depth of the holder subtract the component height, and then you add it to the actual upper height value, because you want to go lower. So you want to add to the upper, which was what we need, and that gives you your height, and then that should work out to be, in this case, about 1490, which I said. Here's an example, and from this example you can see that I've actually, the the upper height is 1310, lower height 1550, depth 2mm, component height 0.6mm, and it all worked out to be 1478 for that example, but in this case I'm going to use 1490. So we've got our heights, we've got our position, so we need to go back to the library and edit our custom LED, because we need to do the pattern matching. So top camera, learn the component, that's our component, next, and like I said, you need one that's reasonably square, so I squared up this one originally, but what you want to do is knock this one to the centre of your, roughly to the centre, then you can use some fine adjustments to set the window to your component. So unlike the feeders, you could use the rotation, all that sort of stuff. What you need to do is you need to actually square this component up as if it was square in a feeder or in a tray or whatever. So you need to square your component. A pair of tweezers, what we've got here, and just square up this component. Move that one out of the way first. So make sure that it is that square. Yeah, that looks square enough. So I don't know if you can see this. This is our window, and I've got it square to the bottom line. You can either do it square to the top line if you want. That makes sure that it is, 0 degrees in the carrier. And then you can use the fine controls to center on component. Open up the window a little bit that way. There you go, so it's center. Now try and keep the window tight on the components in the component trays, because if this component next to it, if that was to land in this window, when it uses a look down camera to search for these components and it finds this one, it'll actually find this component as well. So it'll find the portion of this component in this window, and it'll try and do character recognition, against a component without this little bit in the corner which has got. So it'll fail the actual recognition. So make sure that you do have space around all the components. So that's our pick-up position. There it is. Training. There it is. No problems. A little dot is on the right hand side. Matches the polarity. Run a test, and it finds it perfectly fine. We can drift the angle slightly. Run the test, and it still finds it. So finish. Yeah, short, done. That's the top pattern set. Next you've got to do the bottom, and we learned this one because we've already whacked in the height. Hopefully this will pick up the component without a problem. If it doesn't pick up the component, then you go back into the feeder and you add a small increment, usually 10 or 20 steps onto your Z. So select component, next, tries to pick it up, and picked it up, brought it over to the camera, and as you can see it's nice and square still at the camera. So we can center it again, open up the window, can be a little bit larger this time. Make sure it's nice and square, set your brightness to so you can clearly see the pads and the lands, etc. It's perfectly fine, so I don't really have to do much to that because it was square in the tray. But okay, there we go, that's what it's going to match our bottom to. Again, if you've got any marking, serial numbers, mark them out. Same thing with when training the top camera, I should have mentioned. If you've got a serial number on the top, generally you will, if it's stuff like resistors, chips and so on, make sure that you do mask them out. Next, run the pattern test, yeah, fine, no problem. Change the angles just like before, run the test, and it still finds it. Finished, yeah, done. That's our bottom view, that's our top view. Everything's set, double check, yeah, perfectly fine, okay. footprint is done. All that we need to do is add a part, just say dual LED. Oops, I spelled that wrong, didn't I? Dual LED. Okay, okay. We're in the feeder menu. Load it into your feeder. Dual LED, okay, it's all in there ready to set up, ready to roll, and that's all that there really is to it. So setting up a tray is reasonably simple, and the beautiful thing is, once you've worked out your heights for your trays, your upper height, your lower height, you've worked out your depth, all that you need to do is just to use that final calculation, when all that you got to do is edit the component height. So, you know, for that example, what shows you, it was my depth in steps per millimeter was 120, which will be fixed because it'll be the same tray all the time. And if you use different trays, make the tray to the same height. You won't have to change it ever again. The depth of your component holder, it will be the same again all the time. The upper height, which you're adding on to the end, it will be the same again. So all that you need to do is to measure component height, whack it into that calculation. You don't have to mess about with doing half as many measurements ever again. So yeah, so adding in future components will be really, really, really easy. And yeah, I'll leave you there. Next time it'll be setting up a board, and if you noticed, my fiducials have changed, and a couple of these values have changed where I have pick and placed a board recently. So yeah, and where have we got a program set? Yeah, there's a program set that I ran, and I'll show you how to do this and placing the board in the next video, and after that you should be ready to roll on this machine. Anything else isn't a huge leap of imagination. Yeah, I'll see you next time.